So in the last class we have discussed about direct digital control, in which the computer becomes part of the control loop, right? So we have basically three types of or techniques for doing it. One is inferential, second one is feed forward, and the third one is adaptive or self-tuning control. These are the three types of DDC techniques. First of all, let us discuss inferential control. So this is the block diagram of inferential control. You know that this is the process or the system in which the outputs are measured. Okay, outputs are measured and the controller will take control action and manipulate some variable or control variable. So meanwhile you can see that there is a feed forward path. That means there is a forward path. That means these control variables are also estimated. Control variables are also estimated. Process variables are also estimated, and based on these estimates, the controller is doing something. So why this is required? There are some parameters of the system which cannot be directly measured. There are variables which can be measured, and given information to the controller. But there are some variables which are not measured, that are estimated, or estimated means observed. And these manipulated variables are also estimated, and based on that also the control action is taken. Such a control is inferential control. Okay, why it is inferential control? It is a term applied to control where the variables on which feedback control is to be based cannot be measured directly but have to be inferred from measurement of some other quantity. Such a control is called inferential control. So next, so here some outputs are measured and some which cannot be measured are observed or estimated using an estimator, and based on them control variables are inferred. And next is feed forward control. So feed forward control is usually used in where there is a chance of disturbance. Disturbance cannot be, this disturbance, the effect of disturbance have to be neglected in a system. So what it does is the disturbance will be measured, and the measurement of the disturbance is also considered while taking the control action. So this is the disturbance going to process is measured and informed to the controller, so that controller will take care of the disturbance also. It is not feedback, it is feed forward, because first only disturbance is measured and controller is taking control action based on the measurement of the disturbance. Okay, so this feed forward control. So the effect of introducing feedback control is to speed up the response of the system to disturbances. Then adaptive control, as the name indicates, the controller will adapt to the situation. And controller adapt to a control system with the parameters which vary. There are some parameters which vary. Based on the variation of the parameters, control also will be automatic. Controller parameters are also will be automatically controlled. For example, KP, KI, KD of the PID gets controlled. So there are three types basically: pre-programmed adaptive control or gain schedule control, self-tuning control, and model reference adaptive control. So first is pre-programmed control. This is based on some auxiliary process measurements. Process is there. Not only output is measured, but also auxiliary measurement is done. Some other variables are measured, and based on that we are adjusting the parameters of the controller. They are called auxiliary process measurement. Second is based on external environment. We will be seeing the disturbance will be there. Based on the disturbance, the controller will be adjusted. That is like a feed forward. For example, in an aircraft auto stabilizer, control parameter may be changed according to the external air pressure. Then self-tuning adaptive control. Here what there is a system process and control. This process, from that output will be taken and some parameters will be estimated, and based on that the controller parameters are adjusted. Self-tuning. Tuning is done online. That is called self-tuning controllers. I told KP, KID variation. And the last one is model reference adaptive control. So this is the principle of adjusting the control parameters so that output of the, so what we will do is we will make a perfect model, not actual system, and we will compare this actual system, process and control. So what happens, there will be a reference, same input will be given, and what is expected output we know from the reference model. If that output is based, that error between this output, actual output required, and the actual output, based on that the controller parameters are changed. That is called model reference adaptive control. And the last one is supervisory control. What is supervisory control? Process outputs are measured, and based on that there will be, see, this is parameters are measured, and based on that it will control the gain of the controller. And you know that set points usually given by human operator. Here that is called human is the supervisor. Sometimes computer is used. For example, I told you in the case of throttle control of vehicle, based on the torque and speed, the set point has to be continuously changed. So man cannot assist that in driving. While driving, he is only bothering about kicking the accelerator. He cannot open the throttle and all, or he cannot even tell how much opening angle of the throttle should be. So the computer is, so there will be a computer, sometimes human, sometimes both. They will decide the set point. In normal manual, set point is decided by human being. That human being acts as supervisor. Sometimes computer will be supervisor. It sets the set point, and the output will be measured. And based on that, difference between them, controller parameters are adjusted. Controller parameters means control gain is adjusted usually. This is called supervisory control. So in a gain tuning mechanism, the gain will also be adjusted. In a normal control, supervisory control, based on this error between the set point set by the human or a computer supervision. In human is the supervisor, and based on the error between them, process variables or control variables are changed. In adaptive control parameters themselves are changed. So used in chemical processing industries to optimize the production efficiencies by having a powerful computer which will decide the set point. Human decides the set point, you cannot optimize the product. Understood, I think. Thank you.